Hello and welcome. Today we have a 480E late model we're going to tear down and inspect. This was purchased as part of an engine trans combo by my customer. He's going to be putting everything into an 05 Silverado. It's a 6-liter engine. He's going to be building up to make about 800 horsepower or so. So our job is to build a transmission to handle that kind of power and torque output. So today's mission is to basically figure out what we're working with, determine if there's any hard parts that need to be replaced, and then, ultimately get my customer a report on my findings. So let's begin. All right, this transmission came in with a slip yoke. So you have slip yokes and you have bolt-on yokes, and I believe there's a few different designs over the years. Right now the transmission's in park, so you have your shift lever all the way forward, and this is 15 millimeter, and I think he's got this finger loose. And then from there, you always want to inspect the transmission mount if it comes in with one, but almost invariably they need to replace. So these are 15 millimeters, and then these are all 15 millimeters. I'll get this trans mount off real quick. And then we'll go ahead and take off the extension housing. So these should be on with about 25 foot-pounds or so. Get a little bit further so you can see it. Alright, sometimes I'll come right off, other times you may have to smack it with a mallet or something. So this bushing changed in 2004, and basically the bushing itself is a little bit wider on the outer diameter because the bore changed. The bore was enlarged a little bit, and again that's 04 and up, but you always want to check that because a lot of these transmissions, two-wheel drive, especially late model units, may have an 04 and up extension housing installed. And you can, if you know the part number, you can cross-check it and see if that's in fact what you have, so that you can purchase the 04 and up extension housing bushing separately when you buy your bushing kit. All right, so you're gonna have a lube seal here. I'll take that out later, and then you have your main rear seal along with a snap ring, and then the rear case bushing in there. Take this out of park again real quick. So one of the things I always like to do is spin the shafts. Make sure that they spin freely. There's no signs of binding, grinding, or galling. Okay, it's going to be normal when you spin the input shaft for the output shaft to come along with it in a transmission that's laden with fluid, and that's just simply because the clutches and the steels are adhering to each other and it's spinning. But when you grab the output shaft and hold it, you should be able to spin the input shaft nice and freely without this wanting to come along for the ride. So speed sensors are 8 millimeter. Always replace your electricals and electronic components on these and all transmissions. There's a few exceptions to this, but I won't get into them here. For all the GM units that I work on, that you see me either tear down, inspect, and or rebuild on the channel, that is applicable to all of them. All right, torque 40 for your shift cable bracket. All right, make sure that you get in there. You don't want to strip these out. All right, that'll get put through the cleaning cycle. And then for your wiring harness, all you're going to do is take a mallet and punch it in. These are notorious for leaking through the case connector, and when that happens, sometimes it will short out the whole harness and you'll have limp mode. And that's basically reverse, second gear, and that's it. So for late model 480Es with the center loop design 97 and up, the very first thing you should do is remove this rear cooler line fitting upon teardown. The reason for that is if you don't, and you don't realize that the cooler line fitting actually goes into the center support, you'll never get that gear train out, no matter what else you take off. Alright, I'm going to reorient the camera so you can see a little bit better. Actually, maybe we can let it fly as is. Okay. Alright. 10mm, 17 bolts on the pan. Alright, we don't know the condition of this unit. Like I said, it was purchased as a complete powertrain assembly, engine and trans. He may put a deep paint on here, not sure yet. So all these bolts should receive between 98 and 104 pounds-inch of torque. Okay, that's 98 to 104 inch-pounds. Late model units have a reusable gasket. Alright, so we have a lot of clutch material in here. Again, not uncommon. I mean, you know, who knows where these things have been and what they've been through. So, decent amount of sludge on the magnet. Pretty nasty. Alright, filters. There is an early model and a late model filter. You do not want to mix and match early and late model filters because they are sized based on the pan that you have. Okay, and then as far as your electricals, just take a screwdriver or pry bar and disconnect. Don't worry if you break the tabs. Like I said, you're not going to reuse this stuff. You know, you would never reuse electrical components in a proper overhaul. I mean, I guess if you're on like some kind of budget, maybe you need to, you know, save where you can. You can test these continuity and mechanically if you have all the right equipment and determine if the solenoids anyway are in good shape. Let me pull that off. So this bolt right here for your rear feed tube hold down bracket, this is the last bolt you're going to install and torque when you install the valve body. Okay, the bolt right underneath of it here has to be torqued first before you can even install that bracket. Alright, we got the pressure switch manifold. Let's get that out of the way. And then pay close attention to your routing for your harness if you're not, you know, super familiar with these transmissions already. Come on, gimme. Alright. Now, all these bolts are 10mm except these bolts for the pressure switch manifold. Those are 8mm and a little bit longer. And then on the other side of the valve body where you have your accumulator complex for your 2, 3, and 3, 4 accumulators, the housing there takes even longer 8mm bolts that secure it to the main valve body. So 8mm. So again, if you're on kind of a budget, there are seals and diaphragms on this pressure switch manifold. You can continuity test this to make sure it's working. If you have any codes for any of these solenoids or the manifold or any electrical component, it is my recommendation you just simply replace those parts. But you can replace the seals and the diaphragms individually and otherwise clean this with like some, you know, QD electrical cleaner to restore it if you need to. Again, not what I would do, but you know, and there goes my 10mm socket. There we go. Alright. Alright, detent roller. Valve body bolt to case torque, 98 to 104 inch-pounds. Alright, so here's where you can tell what year it is. It's a '03 valve body, so this trans may be what I would refer to as virginal, in other words, untouched, which would be nice because then you don't have to deal with, you know, somebody else's prior work where, you know, maybe they did everything right, but maybe they didn't. You know, anytime you're going through a unit for, you know, maybe it's your first time or you're not super familiar with them, you really need to be on guard for, sorry about all the noise, you really need to be on guard for a unit that has already been gone through, because you want to make sure that there's nothing that was done incorrectly or improperly. So my recommendation would be to take copious amounts of pictures or even film it, and you can then compare your footage to what you see in the technical manuals or other YouTube videos online or wherever to validate or confirm or deny that everything in the case was assembled correctly by the previous builder. Alright, the servo for your braking band or your coast band, these changed in 2001, I believe. So in 2001, they went to a wider band, and the servo and the band are considered a service pack, meaning you can't interchange one without the other. Alright, so here are all your check balls. This is your number 4 and number 5 check ball. This is your number 8 check ball, and this is your number 9 check ball. For high performance, we're going to be blocking this off, so we're going to delete these 2 check balls. You can delete the flow control check ball for the direct clutch to give you a more robust apply. That's a real good thing to do, especially if you're running a very high stall converter. This is only going to be 2500, so I'm not sure that I'm going to delete it. And then you can also delete the number 9 check ball for reverse if you want better or more robust reverse engagement. Alright, so for your low reverse servo cover bolts, 10 millimeter. These get 18 foot-pounds. Alright, so you have your cover gasket. Alright, that's not reusable. The new one will come in the kit. And then you have your 1-2 accumulator return spring. And then here's your main assembly. Now, in 1996, they went to a dome piston design. In real high performance applications, these have been known to be vulnerable. They will crack right around here. So we're going to install a billet aluminum piston from Sonics when we go back with this thing. Okay, we really don't want to have any vulnerabilities in a roughly 800 horsepower application. So just kind of press down on it on the bench, get a pick, and then you have your little E-clip here, or, you know, snap ring. And they can be tricky. And get this off itself. Alright, that went somewhere, I don't know where. That's kind of the hazard. I think it went back there. It's probably on one of those magnets. So here's how it goes together. Okay, have your seat on this side, your spring, and then your seat on this side. Now these pins are selective, meaning you have different variations based on length, and you can tell by the number of grooves on the pin. I'll flash a chart to show you all the different ones available, but band clearance in the low reverse is absolutely critical. If you get that wrong, you have either too much or not enough, then you're either going to have flaring in reverse, or you're going to have bind-ups. You're also going to wear out severely the band surface on the front planet. Okay, so you have 2 seals here. It's a machine-cut rubber seal on the outer perimeter, and then for your 1-2 accumulator, you're going to have 2 seals here. Okay, some of these in the earlier units and or TH400s had Teflon sealing rings. All 4L80Es should have machine-cut rubber seals instead of the Teflon. So you can retro Teflon, or excuse me, you can retro rubber seals back. That's probably what I would do if you're working on a TH400. get all these seals off, and then this will be ready to go out there in the wash. Same with that. And then your last spring goes just like this in the cover. All right, let me actually get that accumulator complex off the valve body. Take a look at that real quick. Organized here. All right, so again, 8mm. Okay, so this is going to be your third accumulator, this is going to be your fourth accumulator. So like I said, we are not going to be reusing this housing or reinstalling anything there. And then you have your spacer plate, which is straight up bonded to the casting. So let's take a look at the feed orifices, see if they've been modified at all. I don't think so. It's going to be second feed, third feed, and fourth feed. They look virginal to me. So, thinking this thing is literally untouched from when it came from the factory. Like, I don't see signs a shift kit was installed or anything like that. But this is going to take some effort. So we're not going to put that plate back in anyway. That's going to be replaced by a heavy-duty plate from CK Performance. So we're going to do a CK Performance master recalc kit in here that comes with a piston in this machine for a 6-clutch direct drum. So 6 clutches of the factory spec thickness of steel plate. You can do a 6-clutch direct drum using factory components with the bonded piston if you run 6 frictions and 6 forward steels. So, I mean, it's up to you if you want to do that. Let's get some of this fluid out of the valve body. All right, so same deal here. We have a small E-clip. Now you can purchase new accumulator piston kits. If your accumulator pistons are worn out or cracked, it's very rare, I see that. There is an updated kit available that basically retros back to all 480Es, regardless of year. So, I don't have my shop air on right now, but this is where you would blow with the air so that you can extract this piston. So, get it out this way. Alright, we'll mess with that later. Alright, 13mm on your parking pole guide plate. Excess fluid out. Alright, and then you'll notice the way the spring is orientated. Let me zoom in. So you have the catch for the parking pole itself. It's basically facing forward, and then you have the spring, the other portion that hooks onto your stud here that's facing to the rear. This case is wanting to drift all over. Alright, we're going to leave that spring in there for now because I don't want the pull interfering with the rear planet. That's where your parking gear is. Let me grab up all these check balls. You can put Teardown check balls in here. The kit that I'm going to be using, I believe, comes with a full set of those. Teardown check balls will wear the plate out a lot less. Sorry, forgot to zoom back out. I just grabbed the check balls with a magnet. That's all. That's all you missed. All right. 15 millimeter wrench with a rooster comb nut. But first, let's extract the little finish nail-like retainer. Okay, you got to be real careful with these and the equivalent ones in 204Rs. If you break that off in the case, I mean, you're going to have a real big day trying to get that thing out. And that sucks. I've done it before. And basically, it took a machine shop something like a half a day just to get the damn thing out. I got the wrong goddamn wrench. Alright, 15 millimeter, I had a 16 millimeter. Stupid. And this one was on awfully tight, which is good. I mean, you don't want this coming loose. And when you tighten these, I mean, you got to get it on tight, and you really have to double check it. I had one of these come loose on a customer recently, and I know I had that thing on tight, but you know, another consideration is that the threads are just simply no longer viable either on the fastener itself or on the shaft. You know, if that happens to you and you know you torqued it, tightened it, you know, did what you were supposed to do with it. All right, so now we're at the point we can start emptying the main case. So when it comes to end play measurement on these transmissions, you're going to measure rear end play. You have to adjust that using a either the 3-tab steel washer at the back of the case if you're not going to rollerize it, or shims that you will purchase in conjunction with a TH350 pump bearing kit, and those shims will adjust the end play to and fro based on, you know, what thicknesses of shims you install. So when you check end play, this rear section, this has to be loaded. So in other words, pulled or pried fully forward just like this. And then when you have it loaded, then you can check front end play, and you have to net out the travel between the snap ring that goes on the back of the input shaft that secures it to the overdrive planet. So I have 2 different build series on these transmissions that'll walk you through exactly what you need to do. So now we need to remove our 2 feed bolts for intermediate and overdrive. So intermediate is going to be a 3/8 12 point, and then overdrive's a Torx 40. Okay, new bolts come in the kit. If you're going to install the basic Transgo SK4L80 E-Shift kit, my recommendation would be to not use their overdrive feed bolt. That thing loves to strip out, at least it was when I was still running those kits. And, you know, obviously that's no good. Just reuse the bolt that came in if it's in good shape, or if you have a full paper and rubber kit, a new bolt will be in there for you. All right. All right, if you're having torque converter lockup problems, or that was part of the, you know, suite of complaints that the driver cited when it comes in, check this O-ring here. If it's kind of worn out or hardened, then that would be the logical source of the problem. If not, then it's probably the torque converter itself, or possibly torque converter clutch regulator valve in the valve body. All right, eyeball these splines real close. So 13 millimeter on your pump bolts, pump the case. All right, and then to get the pump out, you can use either a large flat-headed screwdriver or a pry bar. So just coming behind here, you have two different places, one on either side of the pump. And then what I'm going to do is I just have my hand over the input shaft so that I can prevent the overdrive section assembly from coming out with it. I prefer not to have that happen. Okay, this washer is selective. This is what regulates your front end play. Alright, so let's see how thick this is. It's good information for me to have as well because I'll record it in my build sheet and then I know what I'm starting with. So this is 90 thousandths thick. These things are not cheap, unfortunately. So if you're building a 4L80E for the first time, this is normally counter to what I would advise you to do, but because they're so expensive, I think they're literally like $15 or $17 a piece, then I would actually advise you to go through the entire exercise of assembling the case and measuring your end play in the front, making sure that the rear section's loaded and that you have everything accounted for. And then from there, if you need a different selective, you can just go buy it individually from a hard part supplier. Okay, old school 4L80Es, 91 to 96, they used one-piece Teflon sealing rings that are kind of like a blue-violet color. They're not made anymore to my knowledge, although I could be wrong about that. I've not seen them in forever, and I wouldn't reuse them anyway. These type of plastic seals are actually very effective, and these seal off the coast clutch. So that's for your coast clutch pack. Okay, always replace your bushings. You can see how worn this bushing is here in the rear of the stator. This will cause issues with the converter as well. It's not something that you want to skip on. If you don't have all the bushing drivers and pullers that you're going to need, then my recommendation is to just simply outsource that particular task to another transmission shop that can R&R those for you for whatever they charge labor, and then you bring them the bushing kit. Alright, 13 millimeter bolts here as well. Let me get my little stand. Alright, late model pumps will have this feature here. This is the casting number 242-03512. Record that somewhere or take a picture of it, because these transmissions from 97 to 07, they had two different port patterns here in the case, and those port patterns correspond to the port patterns in the pump, and it has mostly to do with the cooler line passages. Transgo and the ATRA have information on this. I'll flash it across the screen because I haven't memorized it, but it's something that you want to be cognizant of in the event you have to replace either the stator support assembly and or the case. So make sure you take a picture of the case, and then make sure you take a picture of the stator itself, because if you mix and match them, you're going to have a lot of problems. All right. So we'll look at the working surface here on the stator support. This is what you want to check. You can take a straight edge, kind of put it across and shine a flashlight to see if any light is poking through underneath the straight edge. You can also use that same technique on band surfaces. So any kind of warpage, any light poking through, you're going to want to machine this on a lathe. Okay, you have multiple valve trains in here. This is going to be your boost valve and your PR valve. And then it's going to be your TCC apply valve. This is going to be your converter limit valve. And then over here is going to be your enable valve. Okay, so maybe I'll go through it again so you can actually see. So TCC apply, boost valve, PR valve, pressure regulator valve, torque converter limit valve, and enable valve. So if you're coming to a stop and the vehicle wants to stall out, it's likely excessive wear in the torque converter enable valve. Okay, obviously if the pressure regulator valve is worn, well, you're going to have all kind of problems, shifting and flare shifting, low line pressure, erratic or inconsistent line pressure, etc., etc. So I have videos on vac testing the stator support using the Sonics vac test equipment. That's something you absolutely want to do or have done. If you don't have that equipment, you don't want to spend the money to buy it, no problem. Just, again, another function that you'll outsource to a machine shop. If you're doing a build for performance, you especially want to make sure that this entire casting is up to par. Replace both your bushings as well. Okay, body. I'm going to do a whole separate video using this transmission with this pump body that you see here. I have a video already on the channel that talks you through measuring your gear face to deck clearance, but that's really all I show. Here I'm going to do comprehensive measurements, showing it done both with feeler gauges and micrometers so that you can get a good idea and understand all the different measurements and inspection procedures that you need to perform to validate that this body is good and usable. Okay, so notice this two rectangles right here. This indicates a 97 and up pump body. This could retro all the way back to 1991. You cannot install a 91-96 pump body onto a 97 and up case. So this will go back, but the other one will not go forward. And that applies to the pump body only. So you want to check for wear at the crescent. Okay, had another 4L80E come in, subject of another teardown video, where this crescent over here was heavily worn. And so the bushing was not replaced, and more importantly, the amount of wear that this thing had could have possibly indicated, engine main bearing wear. So anytime you see a lot of wear here on the crescent, that implies the entire gear set, converter, flex plate, and of course crankshaft are oscillating in the main line bore there. So indicates worn bearings. Alright, next thing that's going to come out is going to be our overdrive section. We have a snap ring here. That's for the overdrive assembly itself. One last thing I'll remark about the gears, because like I said, I'll get into the weeds with this in that other video, but you want to make sure the gears are free of scoring or other notable defects. You can reuse the pump gears, it's perfectly fine. Even a high performance unit, they're pretty resilient otherwise, but you want to make sure that everything's good to go. You have a bearing in the back here. It actually goes on the forward drum. So we'll stick it back on the forward drum. And then this is going to be your overdrive planetary section. So you're going to have your snap ring here. This is what I was referring to. This little bit of play. That's usually anywhere from about 10 to 30 thousandths worth of, worth of play, so to speak. So just grab up your snap pliers, and whatever you do, unless you mean to overhaul the overdrive planet, do not touch this snap ring right here. That holds the entire overdrive planetary carrier assembly together. I very rarely, do that. I think it's maybe once or twice I've done it, where I had to actually overhaul the overdrive planet. It's not my preference to do that. It's just, just replace it. Alright, we're not going to reuse this shaft. These shafts are pretty resilient though, to be honest. I mean, upwards of about 700 horsepower. Beyond that, I would run with a billet shaft. If you're going to be racing frequently, regardless, I would run with a billet shaft. You have two sealing rings here and two sealing rings here. These sealing rings will tend to cut grooves in the forward drum, the inner diameter there. We'll take a look once we get it out, but that's something you want to be real watchful for, especially if somebody is complaining about either slipping or delayed engagements in drive, or the forward clutch is smoked. Alright, for your coast clutch, I don't know if the screwdriver is going to work. Nope. Get another one. There's not a whole lot you really need to do here. I mean, the coast clutch is pretty resilient. You just take your planet out and we'll look at the coast clutch. All right, so you have tubular steels. You can retro these back as well if you want. And then check your backing plate. Make sure that it's free of bluing or excessive heat damage. And then you have the little up here, cast into it. That indicates obviously that it should be facing you. So when you look at these frictions, they're Borg Warner. Again, most likely original to the unit. They appear to be in decent shape. So that tells me that this transmission was probably not used a whole lot in towing and hauling. Otherwise, he or the operator would have been in range positions other than drive, and then these would have come on for engine braking and things like that. Okay, we're going to do a whole new steel module, do choline. The steels will not go back in. So this is going to be your overdrive roller clutch. This is the second design. I believe in 2001 is when this was introduced. A lot of builders will actually tell you that they prefer the first design. And I kind of agree with that, because if you compare the size of the rollers with the size of the rollers on the initial design, then you can see an obvious difference. You never ever reuse your one-way assemblies. Always replace those things. Alright, overdrive planet. Check the inner race, make sure it's good to go, it's not burnt, it's not scored. If this overdrive roller clutch fails, then you have to replace the race as well. And this is an example or a situation where you would actually disassemble the planet if the planet itself's in good shape, so that you can swap races. Now, if the planet's also bad, then, well, just replace the whole thing. So inspect visually the gear teeth, check vertical play, check side play, check these splines in here, check this base plate, check the lugs. Okay, these are all the things that you want to scrutinize on this planet. Okay, I say it, numerous times in teardown videos. I'll say it here as well. I don't do any kind of serious inspections until all the parts are cleaned off. Like, there's no point for me anyway to bother inspecting anything, because chances are I'm going to miss something, when parts are dirty like this, laden with fluid. So my advice to you would be to do the same, especially again if you're new to building transmissions or these transmissions. You want to make sure that you're looking at clean parts. Okay, so a little bit of wear in the overdrive clutch, nothing over extraordinary. We have some wear and some sludge on the bottom steel. Again, nothing unusual based on what we have in front of us. He told me how many miles were on this unit, and I don't remember. I think I want to say he said it was like under 80,000. So 4LADEs with that kind of mileage on them are usually in good shape. Even if you had a failure in your unit and you wanted to buy a used 4LADE to kind of tide you over, look for something in that 80 to 100 mile or 100,000 mile range, and it's a pretty good bet if it was maintained at all that it's okay. Alright, you can get this snap ring out by just simply compressing and dislodging the snap ring itself, assuming you grip it right and get it in the right spot, which I'm, for whatever reason, having a problem doing. So you just gotta collapse the spring so that you can get part of the snap ring past that first locking boss, and then you can take a screwdriver, get underneath of it, and just simply go all the way around until you dislodge it completely. And how you see me working it here is how you're going to work it when you reinstall the snap ring. You're not going to use any kind of compressors or special tools to install this thing. You're just simply going to do what you just saw me do. Okay, lip seals. So there's going to be 2 lip seals that come in this kit. All right, they're not interchangeable in terms of where they go. So this is the housing, this is the piston. I should say this is the piston, this is technically the housing. This lip seal here is the smaller of the two. This is the larger of the two. And this lip is facing the short end radius of the housing. And in the piston, the lip is facing toward the lugs. And I'll be honest, I could be mixing up piston and housing. Just the takeaway here is not so much which one is which. I mean, you can check the manual. The takeaway is where those lip seals are pointed. You don't want to get that messed up. All right, next is for drum. Okay, we still have yet to positively identify the source of all that clutch material. I mean, it may just be an aggregation of all of the clutch packs, just generally worn, normal detritus. So again, the bearing faces in this direction. You have the inner portion facing you, and the outer portion installed just like that. All right, you can soak bearings in Dex 3 or 6, doesn't really matter. Okay, so this is going to be your forward clutch hub. We're going to put a Sonex billet steel forward clutch hub in there. We're not going to reuse this one. All right, so check pressure plate, make sure the surface is good to go. It's not like, you know, scored, burned, marred up in any way, shape, or form. Check your lugs too. Okay, they make billet steel versions of this as well. Generally not needed for under, you know, I would say 900,000 horsepower, but it all depends. I mean, if you're in a trans brake operation, or I should say trans brake application, then you may want to consider a heavy duty either billet steel or forged apply plate there, or you know, direct clutch hub. All right, so you're gonna have a washer here, and there should have been a washer here. It's stuck on the direct drum. So plastic washer here, and bronze Babbitt washer there. We rollerize this, you know, these two surfaces when we do performance stuff. Okay, these will like to crack at above maybe 550, 600 at very high RPM. That's why I prefer to replace them. All right, let's check the clutch pack, see what we got. Okay, we have some wear here in the forward clutch. So this is probably, I would say a key contributor, or a significant contributor of all the clutch material in the pan. So you can see it's definitely got very hot. Possibly the source of all the overheating and the reason that the gasket was bonded. You can see slip marks here on the steel. So all heavy duty transmissions, it's my recommendation that you install steel module. I would not reuse steels unless they were absolutely pristine, and I don't see that too often. All right, is your cushion plate. Okay, depending on what you're trying to do, you can eliminate that as well. Main thing is getting your clearance. You can run these, I think, between 30 and 60 thou, direct clutch 10 thou per friction. Overdrive clutch is going to be about roughly 12 to 15 or so thou per friction. Coast clutch is not regulated, and you know, the band clearance for the coast band is not regulated either. All right. I don't think we checked the overdrive pressure plate. Let's take a look at that. So this looks good. I mean, there was no signs of impairment with the clutch itself. The steels look fine, so this is fine. All right, return spring assemblies in the forward clutch. You don't need to do anything fancy. You just need to replace your bonded piston. Same with the bonded piston in the coast clutch. All right, direct drum. Come on. Is this coming out with anything? Nope. All right, so this is going to be your single most problematic clutch in these transmissions. Most of the time, folks doing anything performance oriented, but with the transmission still factory, the direct clutch does not have the holding capacity that it needs to, you know, to keep the clutch pack firmly clamped at wide open throttle when engine power significantly exceeds factory. So we're going to dual feed the direct clutch internally. It is my recommendation you not purchase shift kits that do this, particularly the Transgo HD2. I'm not a fan of that kit at all. I never use it. And the reason for that is that sandwich style spacer plate, plus they have that EPC relief mod, which I also think is high risk. So here is your direct clutch cushion plate. We're going to be eliminating this. And then here are your steels. So this is the bottom steel. See some glazing here, but that's considered normal. Clutch has definitely got a little warm, but they're not as bad as the forward clutch. We'll look at the inner diameter of the forward clutch real quick once I'm done here with this direct clutch. Okay, these frictions look unremarkable to me. I mean, they got the normal amount of wear that you would expect to see for transmission with this many miles on it. And again, we don't have a history, so we can't say what was done or not when it comes to how the vehicle was used. Alright, a direct clutch heavy duty pressure plate is also available from CK Performance. You can purchase that. I'm going to do that with this one. We're also going to install a heavy duty Sonex billet intermediate clutch pressure plate as well. All right, let's take a look at the forward clutch again, or forward drum rather, real quick. So it's in this area that we really want to scrutinize. While it's dirty, I don't see any obvious signs of ring groove or ring cut, but let me wipe it off. You know what, we actually do have wear. You can see it's worn down. I mean, unfortunately I don't have a good used one to compare it to, but this does look actually worn to me, and that would explain why the forward clutch was heavily stressed. All right, intermediate clutch and coast band is next. And grab up the coast band. Again, roughly normal amount of wear. Otherwise, nothing really remarkable to mention. Alright, let me get some of this stuff kind of out of the way because we gotta take out the whole gear train. So we have an intermediate clutch snap ring. Get you a little bit more zoomed in so you can see. So we have our intermediate clutch snap ring. This thing is flimsy as hell. You would not want to reuse this in any kind of performance build. In fact, none of my 4L80Es receive the factory snap ring. This gets deleted every single time, and we replace it with a Chrysler A518 forward clutch snap ring, and I typically run the 88,000 stick version here. Intermediate clutch clearance, it's a pretty wide range in terms of what the factory calls for. Something like 40 to 125 thousandths or an eighth of an inch. The higher the RPM application, the more clearance you want in this pack. Okay, it is very efficient in terms of how much fluid gets in there and how quickly. So you're not going to have an issue with slipping or soft shifting or flare shifting. You know, too long of a shift in most cases, as long as everything else is up to par as it needs to be. So here is your cushion plate, and then this is the bottom steel. You'll notice that this steel was machined, force machined, all the way around. Interesting. Okay, we have heavily stressed intermediates. So you see slip marks here. Clutches are heavily stressed and burnt. Not quite coned, but okay, pressure plate. This will not go back in. We're going to be installing a Sonex pressure plate. Sonex pressure plates are about $50 to $60 depending on where you're getting it, but if you're doing anything high performance, I would recommend you install it just as an added, security measure, if you will. All right, so we have our snap ring for the center support itself. That has to come out. 91 through 95, I believe, the piston in the intermediate clutch was different. In fact, that was a late model TH400 piston that carried forward into these early 480Es up to 95. 96, they introduced a different piston and this cushion plate. This is a beveled snap ring, so the flat side is going to face inboard, to the rear of the case, and then the other beveled side is going to face up. Just kind of work it free all the way around until you can maybe get a hand on it, and then at that point you can start freeing it up and it'll eventually come out. What I'm trying to avoid here is, like, you'll notice all this fluid pulled down in there. I'm trying to avoid a bath. So that's why I'm being a little more gingerly with it than I otherwise might. So you'll notice the bevel faces us. Get that in focus. So there's the bevel, and then here's your flat side. Alright, now what I'm going to do is I'm going to go grab a tool. This tool will allow me to lift this entire gear train out as one unified assembly without risking, having parts come loose or spill out into the case. Alright, so here's the tool in question. This is a lifting tool. You're going to use this to lower that whole assembly into the case carefully when the transmission is on the stand during final assembly. So just grab the output shaft and then push and pull forward. Get it to where you can grab the stator on the center support, carefully lift it out, and get it on the bench. Alright, 99 up, they changed gear train design. They changed the design of both the front and rear planets to take taller pinions. So this planet and this planet cannot be retroed back to a 98 and back 480E at all, just individually. And they cannot be retroed to a 96 and back, period. So you can retro this entire gear set as a service pack. Everything you see in front of you here, from the main shaft to the output shaft and everything in between, to a 97 or 98 unit as a complete assembly. Now, if you're working with a 98 and back unit, you're going to have the legacy style or first design front and rear planet. You can mix and match those between earlier and later units. Okay. So two-wheel drive, you'll have your reluctor gear here. This is necessary for the speed sensor. It's also necessary to have this for 91, 93 4x4 units as well, because they had 3 speed sensors in that command and control strategy. In 94, they eliminated the output speed sensor for four-wheel drive 480Es, and they just went with the input speed sensor and the transfer case vehicle speed sensor. Okay, so here is your race for your center support that goes down here. So we'll stick it back on there for now. And then you have a bronze Babbitt style thrust washer. So dig that out. And for your return spring assembly, we're not going to reuse this. For all high performance, you want to use a heavy duty thick spring retainer and high rate return springs for your intermediate clutch. Alright, you don't want clutch drag when you're taking off in first gear, especially if it's a trans brake type application. You're launching at like 6,000, 7,000 RPMs. Last thing you need is clutch drag in that intermediate, and that's where you want probably anywhere from 100 to 125 thousandths clearance in the intermediate clutch. Okay, here's your piston. This is the part number for the 96 and up piston, ends in 553. There may be other part numbers. And of course your lips, they face downward into the board, the center support. Alright, you can buy billet pistons too if you need to. Very, very high, high horsepower, high RPM applications, 7,000 plus RPMs, 1,000 plus horsepower. It's probably a good idea to put a billet piston. Check your sealing surface here, and then you have your 4 sealing rings. This one right here, the second from the top, is omitted when you're dual feeding the direct clutch, and then you leave the center seal out of the direct clutch itself, the drum, and you block off the high reverse feed passage in the case. And that's going to be, if you're looking at the case, with the worm tracks facing you, it's going to be on the right side. Now if you're doing trans brake, the instructions will tell you to block the direct clutch feed passage, reverse pattern, manual valve body and all. So let me get these off of here. Alright, always replace all your bushings in the 4L80E. These things are very hard on bushings. Do not skip that step. Center support bushing, bushings in the gear train, bushings elsewhere. You saw how worn out the bushing was in the forward drum. I mean, these are very hard on bushings. And so you need to do that if you're going to do a proper overhaul. And again, if you don't have all the equipment and tooling for R&R it yourself, just simply outsource it. As long as it's done and it's done correctly, it doesn't matter. Okay, you got a small seal here. This will come in the kit. If I can dig that out real fast. It would help if I had a pry bar that was sufficiently small enough. While I have it, I'll take the selector shaft seal out. So there's a selector seal. Alright, now I want to go ahead and remove that parking pole spring there. It's no longer a concern about stuff being in the way. Center support itself, you want to check your race, make sure it's good to go, make sure it's not burnt, no signs of damage. 7225 is the part number. Make sure the lugs are in good shape as well, TH400s. These lugs would fret against the case in the very early units. 60s and very early 70s, I think in 70 or 71, they introduced the anti-fretting ring. So it should be in here, and that was carried forward into the 4L80Es. So here's your anti-fretting ring. Very thin, just basically protects the case against fretting from the center support. Okay, so here is your one-way clutch, low roller clutch assembly, and then your front planet. And then here's the bearing assembly. I'll put it back so you can kind of see how it should go. Alright, so front planet is going to have a 2-tab washer for anything, I believe, 01 and up or 02 and up. Prior to that, they had a 4-tab washer. If you're going to rollerize the rear of the case, there is a Babbitt washer. Here it is in the case. It's a Babbitt washer. You can take this 4-tab Babbitt washer for these late model units that take only the 2-tab, and it might have been 99 when they actually introduced that with the taller planet. You can lop off 2 of these little tabs and run this here. They're the same thickness. So I typically do that because it's just, plastic is not as strong as Babbitt. Okay, check your band surface. You see this band has grooves from the factory. That's, that's normal. That's how it was manufactured. Okay, check pinions. Check the rest of the surface. Check the cam for your rollers. Make sure it's not excessively worn. I've never actually seen one bad. This bushing will be replaced. This planet appears to be in good shape. A lot of times you'll see severe warpage here because of band clearance that's too tight for for the planet. All right, so here is the first of the 3 bearing assemblies in the back here in the gear train. So you have 2 races and the Torrington bearing itself. This is really more like an axial bearing. So this part goes into the bottom of the center support just like this. So it's this portion here faces your bearing, and then you have the bearing itself. Okay, most of the time these are in good shape unless there's like a total catastrophic failure in the back of the unit. And then you have your inner race, and that goes just like this. So they sell bearing kits as well. If you want to replace your bearings, you can. Certainly no big deal. All right, Sun Gear and Sun Gear shaft. Billet steel versions of this are available, as is for the main shaft. We're going to do the main shaft. I may do the Sun Gear shaft as well. You want to make sure that this lube hole is lined up with the lube hole in the Sun Gear shaft. Okay, so take a flashlight. I'll get a flashlight real quick if I can find it. Where's my flashlight? Okay, you want to be able to see light coming out of that little lube orifice. Okay, I have a whole video on lube mods for 4LADEs that you'll want to check out. There's a variety of different lube modifications that you can do to these things to ensure that more lube oil gets to sensitive areas like planetaries, gear sets, and sprags, one-way clutch assemblies, and the like. So it's on the channel. I think I filmed that about 2 years ago or so. All right, I'm gonna reposition the camera a little bit. There's a hole right here in the bench. Obviously you can't see it at the moment, but we're gonna stick the rest of the gear train in there so that we can take the rest of it apart and look at it. Alright, so you have a snap ring back here. This is going to retain your rear planet to your output shaft, to your rear ring gear, to the main shaft. And let me see, I'm getting a different screwdriver here. Alright, it's early in the morning, we got people leaving for work, so that's kind of what you're hearing in the background. This snap ring's pretty tough. It might be a two-tool job. So try to get in behind it. I normally don't struggle with these, but because I'm filming, I'm going to be struggling with them. There we go. Alright, it'll want to fly off at you as well. So here's the second bearing. So again, you have your main shaft, and you saw part of the third bearing assembly. So you got your rear ring gear for the planet. Come on. Wants to be difficult. So goes together just like this. So you have your bearing, your outer race, and your inner race. And then that whole thing goes on here like that. Alright, so I'm already seeing some signs of lubrication issues. You see some fairly heavy scoring here on the journal. So, you know, it's something you want to keep eyes about. So let's talk about the second bearing assembly, because this is going to be something critical if you're not already familiar with 4LADEs. 99 and up, as I mentioned, they changed the design of these pinions for both the front and the rear planet. They're now taller. The housing here, this area in particular, is thinner than prior planets. 1998 and back. So here is your third bearing assembly, and this is going to be the largest or the widest of the three of them. So this is a 41 thousandths shim. What this does is it recenters the sun gear for the two planets so that it, you know, they're not out of mesh. So this goes under here just like this, and then you have your inner race, which is this, sorry, you have your bearing, and then you have your outer race. So this is how they go. And you notice lube channels are cut in. Okay, you don't have to worry about lining these up. I mean, as the whole rotating assembly is working, lube oil will get to where it needs to go through these cutouts. Alright, so let's inspect the output shaft. This bushing gets replaced. Check this journal, clean it up if it's a little marred, or it's got some what am I trying to say here? Some, I guess, not slip marks, but or you know what I mean. I don't see any on here. Glazing, that's it, glazing. Okay, check your splines as well, check your engagement lugs, and just make sure that the rest of the structure is in good shape. These are very, very resilient. I mean, you can get billet steel shafts too, but at some point, you tend to spend money where the principle diminishing returns applies at a given horsepower level. Now, if you're doing pro mod stuff, well, I mean, I don't think you ever get to that point, because you're spending, I mean, if you have an infinite amount of money, the transmission is still going to have to come out periodically for refresh and to replace broken parts. All right, so a little snap ring here. And it looks like it wants to fight. And there it goes. Landed safely on the other bench. So, gotta watch. I mean, you can put your hand over it like that, make sure it doesn't fly away. I probably should have done that, but then again, you wouldn't have been able to see what I was doing, so that's why I didn't. So note the lube orifice or lube channels here. And then for your main shaft, note that this is solid through and through. 9196 with the rear lube design, traditional lubrication circuitry. That shaft was hollow inside, so they're not interchangeable. Okay, check teeth, check surface, do all your usual inspections. I may need to put another ring gear in here. And then these reluctor gears, or whatever you want to call them, they are available separately. So if you're trying to convert 4x4 to two-wheel drive and you're working on a later model unit beyond 1993, then you can press on or install a reluctor gear onto the Planet, and you can have two-wheel drive functionality, because you need this on here for the rear speed sensor to work as the vehicle speed sensor. All right, there's a band in here. See if we can get it out. Okay. Always replace this band if you're going back through the unit thoroughly, which thoroughly is really the only way you should be doing it. A lot of shops consider this a hard part, however, and they will not replace the band. So, some bands were perfectly smooth. Some bands had like grooves in them, like you saw with that drum. Let me get this band back here. It's going to be hard to tell, but... So this is a smooth band. I don't see any, grooves or anything like that. And then just looking at the friction material, it does look worn out. So I would not, even if I was the type of shop that considers that a hard part, I would not reuse that band. So customer would just simply be paying for a new band. All right, and lastly, you have your 3-tab washer. We're not going to reinstall this. A TH350 pump bearing will go in the back. When you install the TH350 pump bearing, you need to install it such that the black side of the bearing, the inner portion, faces rearward. Okay, because the gear train is what rotates. The back of the case is static, obviously. It's just, hard structure. And so when you have your bushing installed, and you can use a TH400 bushing in here, You do not want that inner portion of the bearing rotating directly against the bushing that's locating it, because eventually that bearing will cut into the bushing and lop it off, and then you have nothing back there keeping your gear train on centers. So just keep that in mind. Like I said, I have 2 videos, and both of them rebuild series show how to install that bearing. Before we summarize, I want to circle back to the direct drum. I never took the sprag out. So first off, you want to inspect in here for sealing ring groove wear. I hardly ever see it, to be honest, but it's something you still want to check to make sure that there's no excessive wear, no sealing ring cut, from the center support rings into the inner diameter of the direct drum. So this is a spiral lock style snap ring. It's my recommendation you employ this pretty much on everything. TH400 wise, they're standard on the 4L80Es. So anytime you can add a little bit of extra security here, it's always a good thing. So there's 2 locks, one here and then one right here, where it's getting kind of hung up. So you kind of have to just get in with your pick and break the lock, so to speak. And I don't mean physically break the tab off, you just have to decouple it, that's it. Alright, so sprag rotation is going to be clockwise, lock counterclockwise, 34 element sprag. That's what you want on all 4L80Es, in my humble opinion. So if you have an early 4L80E, or if you're working with a TH400 and it's making any kind of power at all, with the engine in terms of what it's outputting, always install a 34 element heavy duty BorgWarner sprag assembly. So just like all your other one-way assemblies, you'll replace this. You really, at least for me, I don't want to just generalize this and apply it to everybody, but for me, I really usually cannot tell how worn a sprag is, so I just simply replace it. And then drum itself, you have your snap ring, high rate return springs in a direct drum if you're going to be doing performance oriented builds, and that's what we're going to be doing here. Alright, I want to revisit the intermediate clutch pack as well. So when you have what we saw earlier with respect to heavy clutch stress, as well as unusual wear and or quote-unquote machining in one of the steel plates, the bottom steel here in this case, you want to try and figure out why that happens. So when it comes to stress on the clutch pack, first thing you want to look at is these lip seals. You want to see if they're hardened, any tears, any other defects that would readily explain why the intermediate clutch burned, or any clutch with any piston with any lip sealing surface. You also want to check for cracks on the structure itself. This piston looks perfectly fine to me. No signs of any fractures, but like I said, it's still kind of dirty with fluid, so I'll take another look at it once it's all clean. Okay, so 4 frictions, 4 steels is your standard stack up. These are definitely stressed, but we don't see a ton of slip marks, a ton of signs that this clutch was slipping per se, but we definitely see what appears to be some sort of compression driven wear here between the cushion spring or wave plate and the bottom steel. So as I mentioned earlier, check this surface area in here. Make sure there's no burrs. That would also explain, burnt or heavily stressed clutch pack. I don't see anything. But when I was manipulating the transmission when it was fully assembled earlier, spinning the 2 shafts and kind of loading the rear section, I did notice that there was a lot of end play in the rear of the transmission. Like a lot of end play, and I think what was happening was, and again it's just my theory, but I think what was happening is we had more end play in the rear than we did in the front after netting out the slop and the snap ring between it, the input shaft, and the overdrive planet, and this transmission was binding up from a case components travel perspective, And so something had to give, some clearance had to be created, and I think that's what was happening here. The entire gear train, which of course the center support is part of, was, you know, binding up a little bit against the clutch pack. I mean, I could be wrong. You know, you do have a snap ring and a bolt securing the center support, so that may not be as viable a strategy or as viable as an explanation, but when you have more in play in the rear than you do in the front of these transmissions and TH400s, you will have binds in the case between the rotating assemblies. So that's the only thing I can think of off the top of my head, you know, based on what we observe in front of us, you know, the evidence, so to speak. So I just wanted to touch on that before we summarized. All right, I have not performed vacuum testing yet, so absent vacuum testing on the stator and the valve body, for the most part this unit is in decent shape. Get the camera, it was a little cockeyed. For the most part this unit was in decent shape. Okay, a little more wear to it than I would have expected for 80,000 miles, but I am confident that the majority of the friction material that we saw came from the forward clutch pack and the intermediate clutch pack. And so I'm going to have that forward drum there sleeved with a ductile iron insert, and that will basically prevent any future occurrence of ring groove or ring cut or whatever by the input shaft sealing rings. The planets, all three of them, seem to be in good shape. Bring that planet back. I know this was literally like 5 minutes ago, but I can't remember if I actually went through this checking process or not. I think I did. You know, when you're filming, you're going to find that half your attention is on what you're doing. The other half of it is on filming what you're doing, making sure that your camera angles are where they need to be, making sure you're not zoomed in when you shouldn't be. That's a serious problem with me. I tend to forget to zoom back out. But anyway, the pump, we have to measure clearances. I'll do a separate video on that once it's all cleaned up. We'll measure them using those gears, and we'll show you two different ways to do it, using straight edge and feeler gauges as well as micrometers. We'd need an inside micrometer, an outside micrometer for the gears, inside micrometer for the diameter of the pump pocket, and then a depth micrometer so you can measure and calculate your clearance between the top of the drive and driven gear and the deck surface. So look out for that. It should appear on the channel shortly after this video, and that will walk you through step by step procedurally on how to ensure that the pump body is in good shape. All right, you want to drill out the drain back in that pump body to 1/4 of an inch. That will promote better and more efficient drain to the sump. And also prevent fluid from piling up behind that front seal and you know, potentially blowing it out. I've only seen that once, I think, so I don't think it's as huge of a concern as, you know, the internet may make it out to be, but it's something that takes off, you know, 30 seconds to do. So it's good preventative maintenance if nothing else. All right, that's a teardown. So hopefully it was informative for you. Like I said, replace all your electronics, care for your hydraulics, replace any hard parts that are bad, replace all your one-way assemblies. Bearings should be reusable unless there was a total grenade at the back of the case, then I would replace. Same with major overheating. And then dual feed the direct clutch internally. Do not use the Transgo HD2 shift kit. That thing is no good in my opinion. I love Transgo stuff for the most part, but you know, that one was kind of a rare miss for them. So, all right, thanks so much for watching, guys. Greatly appreciate it as always. And stay tuned for that other pump video. Till then, have a great rest of your day and evening.